Hello, in this video I want to compare linear versus exponential models for the same scenario. So let's suppose we have an experiment and it says at the beginning of the experiment you have 100 bacteria and they're fed regularly, and then 4 days later there are 300 bacteria. So the idea is you have an input, which is time in days, measured in days, and then the number of bacteria is the output. So your 2 points are 0, 100 when you start out, and then 4 days later you have 300. So our question is then, is this linear or is it exponential, or can we come up with a model for each one? We really don't know. So here are the 2 points if it's linear, but the model between it is a straight line. And here are the same 2 points, but if it's exponential, you start having an exponential curve between them. And again, the model, when you look at the actual equation of the lines, you have mx plus b for the line, or I like to write it b plus mx. So you have a starting amount, and to that you add or subtract, depending on the sign of the slope, a certain amount. But the process is addition or subtraction. And here with exponentials, you have a starting amount, and then you multiply. And so the process here is multiplication. So which one, let's do a model for each one. All right, so let's suppose we look at the linear model. All right, you have the 2 points, 0, 100, and what was it, 4, 300. And you know your y-intercept is 100. So let's look at your slope. Your slope is, y2 minus y1 over x2 minus x1, which is 300 minus 100 over 4 minus 0. So you have 200 over 4, or 50 over 1. So your slope, is 50. So your equation is y equals 50x plus 100. And again, your scenario that you're given here so far is 0, 100, and then 4 days later you have 300. And what happened is when you went through one cycle of 4 days, you added 200. So the idea is if you go another cycle, you go to 8 days, we should be adding another 200, so we'd have 500. And go another cycle, go to the 12 days, you would add another 200, so you're at 700. So the idea is you're adding, and we can double check and just see what happens if we have like 8, 5 times 8 is 40, so 400 plus 100, 500. So there's your model, it checks out. But the big process here, the big takeaway is you're adding, right? So now let's do the same thing with the same 2 points, but let's look at an exponential model. Okay, same 2 points, 0, 100, 4, 300. So the idea is we have the form y equals a times b to the x, and we can go ahead and put in, we know a is 0, but let's just put this point in. So the technique is essentially to put the points in. So 100 for y, 0 for x, and anything to the 0 power is 1, so you have 100 is equal to a. So there's your starting amount. And then we're going to put in this point, so y equals 100 times b to the x. So we're going to have here 300 is equal to 100 times b to the 4th. Now if I'm going to solve that, I'm going to divide both sides by 100. So 300 divided by 100 is equal to b to the 4th. So 3 equals b to the 4th. And b, well, I have to take the 4th root of both sides. And technically I would have the absolute value of b is the 4th root of 3, but we can't have negative bases, so we know it's going to be the positive. So we're just going to leave it the positive. So technically positive or negative, but we're going to say positive because we know that. So another way I could write it is 3 to the 1/4. So our equation then is y equals 100 times 3 to the 1/4. And so what you're seeing is your process, right, is you start out at 0, 100, and then was it 4 days later you have 300, and we multiplied by 3. And so there's that multiplication right there. And so when we go to the next cycle, 4 days later, you multiply by 3, and you're going to have 900. You go to the 12 days, you're going to multiply by 3, right? You're going to have 2,700. Now let's just check our equation. So if we have, so I want to put in 12, I'm sorry, that's 3 to the 1/4 x, right? That's our, sorry. There's our b is 3 to the 1/4 and then to the x. But we really would write it y equals 100 times 3 to the x over 4, right? All right, so let's go ahead and put in 12. When we put in 12, right, we're going to have in, so y of 12 is equal to 100 times 3. 12 divided by 4 is 3, so 3 cubed, right? So let's go ahead and check that. So we have 100, times 3 raised to the 3rd power. There's your 2,700 right there. So again, it depends on which, we don't know what process we have. How would we know? Well, we would know after a little bit of time which process it is, whether it's linear or whether it's exponential, because already by day 12, here you're at 700 and here you're at 2,700. So that's a pretty big difference. And you could even go a couple more cycles and then you'd really be sure, because there's such a difference, right? Because essentially you're going to have either something more like this or like this, and this spread starts to get very, very big, right? And that's when you can tell. Now, one little last note I want to make is, if you want to know per day, here we're doing it every 4 days, we're multiplying by 3. So what you can do is you can actually find what is 3 to the 1/4 power. What is this right here, which is b? So I can say 3 raised to the 1 divided by 4. And I get 1.316. You do have to go quite a bit. So b, quite a few places out. 3.1607. Okay. Oops, I wrote it the other way around. Sorry, I switched these. 1.316. Oh my goodness. I need to write it all out again. Forget this. 1.31607. And it's an approximation. So if you were to put that in there, in this place, and you went 100 times 1.31607 to the 12th power, you should get 2,700 also. So we can do that. 100 times 1.31607 to the 12th power. And, you know, it's an approximation, so it's close to 2,700. All right, thanks so much for listening.